Section 4.3 offers you a third way to solve a system of equations, and it is by elimination. Elimination just means to remove or get rid of. And so we're going to go to example 1 to see what does that look like if we're trying to remove something. We want to remove a variable, and that would let us find our x comma y, whatever our intersection point is. So if we look at these two equations, we are going to notice that they're both in standard form, and the y variable and coefficient number in front of it are opposite signs. So the first thing we want to notice here is this is a minus 4y and a plus 4y. Think about what would happen if we were to add those together. Negative 4 plus 4, those would add to be 0. And when you have two equations like this that have terms that would add to be 0, we can add both equations together, and that will eliminate and remove, get rid of, that y variable since they are opposites, that negative 4 and positive 4. So that is what we're going to do in this first example, is we're going to solve these just by adding the two equations together. So think about it like when you first learned addition and you had something like 6 plus 7 and you stacked them vertically and you added them. That's what we're going to do here with these two equations. We're going to have our two equations, 2x minus 4y equals 2. We're going to add that to negative x plus 4y equals 3. We can do this because our equations are both in standard form and our variables perfectly line up. The x's are on top of the x's, the y's are on top of the y's, and the constants are together because they're both in that standard format. So we can draw a line underneath and we can add this just like we were originally taught to way back in elementary school. If we have 2x plus negative x, that's 2 plus a negative 1. That's 2 minus 1. That's just x. We could write 1x or just x. So we did the x's. Now we're going to add the y's, which was what we looked at first. That minus 4y plus 4y is going to add to be 0. No more y's, so that's just plus 0, or we don't even have to write it. And then we're going to add our c value constant term at the end, 2 plus 3. So 2 plus 3 equals 5. So we have added both of these equations together, and you guys, you're going to see we created a new equation. X equals 5. Look at that. We know our answer needs to be our intersection point, our x comma y. And in this case, our x is 5. We used elimination, and we added to eliminate the y, and now we know our x. We can now use one of the equations to find our y and use that substitution that we touched on in the last section. So if we have the equation 2x minus 4y equals 2, and we now know that the x is 5, that can be 2 times 5 minus 4y equals 2. And we can substitute, and now we can solve that. 2 times 5 is 10 minus 4y equals 2. We can subtract that 10. You end up with negative 4y equals negative 8. If we divide by negative 4, we end up with y equals a positive 2. And that is our y value of our intersection point. You, of course, can use Desmos to graph both of these equations and check that answer. But elimination could be a quick way when you see that you have a positive and negative of the same variable. Let's do another example. Look at example B. Our two equations are 2x plus 3y equals 1 and negative 2x plus 2y equals negative 6. Can you find the two variables that would add to be 0? It's that 2x and that minus 2x. Notice that everything's in standard form with our x, y, then our equals our constant. And so we can stack and add those. 2x plus 3y equals 1. We're going to add that to negative 2x plus 2y equals negative 6. Let's add 2x plus negative 2x just as 2 minus 2. Those eliminate. They remove each other. They add to be 0. They're gone. And now we have 3y plus 2y. So if I have 3y's and I add 2y's, I'm at 5y equals 1 plus negative 6. If you add that 1 minus 6, that's negative 5. And we can divide by 5 to get our y by itself, and we find that our y value is negative 1. So we're working on finding that ordered pair intersection point. We don't know our x yet, but our y is negative 1. Remember, the y is the second term. And now we can find our x using either one of our given equations. I'm going to use the first one, 2x plus 3y equals 1, and we now know what y is. We know that y is negative 1. So that's going to be 2x plus 3 times negative 1 equals 1. Let's do that. 2x plus 3 times negative 1 is negative 3 equals 1. If I'm going to solve for x, I need to get it by itself. Start by undoing that minus 3, so I'm going to add 3. 2x equals now 4. If I divide by 2, x is going to be 2. So our our x value, our x is 2, and we have our ordered pair 2, negative 1. You again can use Desmos to check that. If you like the graphing, you can use that to check your work, but this is just another way that you can solve a system of equations by elimination. Now we're going to turn to page 164, and you're going to look at number 26, because we are going to apply this to some real-life scenarios. Number 26 says 2 pizzas and 4 sandwiches cost $62, while 4 pizzas and 10 sandwiches cost $140. How much does each pizza and sandwich cost? And what we're going to use is our standard form model of AX plus BY equals C to set this up. This is perfect because this model has an X and a Y variable that represents two different things. And in this case, what are the two things we're comparing? We're comparing pizzas and we're comparing sandwiches. So let's let pizzas be our X and sandwiches be our Y. All right, we've got our two variables, our two unknowns, because we don't know how much each one of those cost. And we can set up an equation to model this. So the first sentence says 2 pizzas and 4 sandwiches. So that's going to be 2 pizzas, which is X, plus 4 sandwiches, which is Y, cost how much? Totaled how much? $62. So we've set up our first equation. Amazing. Let's do that same thing with our second equation. 4 pizzas and 10 sandwiches cost $140. All right, look at that, you guys. We have set up two equations to represent those two sentences. And we've made sure that how many pizzas were connected. So it was 2 pizzas, then 4 pizzas, so then 4x, 4 sandwiches, 4y, 10 sandwiches, 10y, and those totals were on the other side of our equal sign. So we make sure we keep our variables together. We know that x is representing pizzas and sandwiches is being represented by y. And let's now use Desmos to solve this and find that intersection point. That might be the easiest way because we're not set up well for substitution. We don't have a variable by itself, and we can't really use elimination because this is a 4y and this is a 4x, but they are not aligned. They're different variables and they're not opposite signs, so they won't eliminate each other. So let's use what we know about graphing and Desmos to find that intersection point. So I'm going to go to Desmos, and I want to graph these two equations. So we want to graph 2x plus 4y equals how much? 62. And then we want to graph 4x, I'm getting faster at this, here we go, plus how many y's? 10y equals 140. Okay, look, whoa, where's our graph? Well, these numbers are really big, 62 and 140, so maybe we need to zoom out. Oh, that was in. We need to zoom out. Okay, cool. Then we found it. That point is at 15, 8. So let's come back to our notes, and we just found that our intersection point is at 15, 8. Well, what does that mean for us? Like, let's look at this. We graphed it on Desmos. It looks like this. Our intersection point is at 15, 8. Well, let's remember that an ordered pair is x, y. So the x is 15, the y is 8, and in context of our problem, when it says how much does each pizza and each sandwich cost, well, the x represented pizza, so that means that pizza is $15 and sandwiches is $8. We just had to make sure that we knew that the x represented pizza and the y represented sandwiches, and now we know the cost of both of them. So look at this example and pause and check out number 27. You guys try that. All right, let's check it. If we were writing our two equations, we had a clothing store, had 3 shirts and 8 hats. So I would call that 3x plus 8y equals 65. And then the cost for 2 shirts and 2 hats is 30. So that'd be 2x plus 2y equals 30, where my x represented shirts and my y's represented hats. So you went to Desmos and you graphed this. Let's check it out. Did you find the intersection point at 11,4? Which means that x is 11, the y value is 4, and if the question said how much does each shirt and hat cost, that means shirts are $11, hats are $4. There we go. That is how we can apply some real life to our system of equations. It can help us find the price of something if we didn't know how much each individual thing cost, but we knew how many we got and how much we spent. All right, you guys, that was 4.3.